So here we have an example problem for a block and tackle pulley system. So right up here's our word problem. A block and tackle is used to lift 475 pounds with 45 pounds of effort. So we know that 475 pounds is our resistance force and 45 pounds is our effort force. Now you can see that there's nothing listed here about distances. You can use distances to figure out IMA of a pulley, but there's an easier way to do that. IMA of pulley systems, if you have a fixed system, IMA is simply 1-to-1. If you have a movable pulley system, it is simply 2-to-1. And if you have a block and tackle system, you can see down here on your formula sheet, IMA equals the total number of strands of a single string supporting the resistance. Another way of saying that is all of the strands that you count that are opposing the load, that number, that whole number is your IMA. Okay, opposing the load. So that means if you're pulling down on one, you don't count that one. But all the ones that are supporting it, you do count. All right, so let's get into the problem here. Again, a block and tackle is used to lift 475 pounds with 45 pounds of effort. So my resistance force, FR, equals 475 pounds. And my effort force, FE, equals 45 pounds. So we have the numbers here. The first thing that we're going to do is we're going to calculate the actual mechanical advantage, or AMA. So AMA, and it doesn't matter what simple machine we're talking about, AMA is always FR over FE. And we'll substitute those values in. So 475 pounds divided by 45 pounds. And if we plug that into our calculator, we get 10.5 repeating. And again, the units cancel each other out, so our AMA is 10.5 to 1. So the next question, if you're designing this block and tackle system, might be, well, how many strands do we need? How many pulleys do we need? So what should the IMA be is another way to put that question. So the number of supporting strands of this block and tackle system would have to be greater than what the actual mechanical advantage is. We know that IMA is going to be a whole number that corresponds with the number of strands. So IMA is always greater than AMA. So your minimum number of supporting strands for a block and tackle system that's going to give you an AMA of 10.5 or more would be 11 strands. If we have an IMA of 11 to 1, which this would imply, we can then come up with what our efficiency would be as well. And our efficiency is always AMA over IMA times 100. So our AMA equals 10.5 divided by our IMA of 11. And we end up with an efficiency of 95.4, 95.5.